Let's do example 12. A greengrocer purchases oranges from two different wholesalers, so Sunblest and Valencia Star. He takes 5 random crates from each wholesaler and counts the number of blemished oranges in each. Find the mean and standard deviation for each dataset and hence compare the wholesaler suppliers. Okay, so first we have Sunblest, and then we have Valencia Star. So we have to find the mean first. Let's call this x1. So the mean here is just you add all data values, so 4 plus 16 plus 14 plus 8 plus 8, and you divide by the number of values that you have in your data set, which is 5. And if you do that here, then you get 10. And you do exactly the same for Valencia Star, so let's call it x2. So 9 plus 12 plus 11 plus 10 plus 13, and we divide that by the number of values that we have in the dataset, so divided by 5, which gives us 11. So we see here a 10 and here an 11, so we can say that the sunblessed oranges generally have less blemishes. So the sunblessed oranges generally have less blemishes. So the sunblessed oranges generally have less blemishes. Okay, and now we also have to find the standard deviation for the first one. Let's call that S1 is equal to the sum of the deviation squared divided by the number of values in our data set. So let's first find the denominator in our square root here. So with the sum of the deviation squared so that is the first value that we have, the 4 for example here, minus the mean, which is 10 squared. Then plus the second value, so 16, minus 10, the mean squared, plus the third value that we have 14, minus the mean, which is 10 squared, plus the fourth value 8, minus 10 squared, plus the fifth value, which is also 8, minus 10 squared. So instead of copying the fifth value, because we see that the fourth and the fifth are the same, we can just do 2 times 8 minus 10 squared. And if we do that, we find out that it's equal to 4 minus 10 is minus 6 to the power of 2 is 36, 60 minus 10 is 6 to the power of 2 is 36, 40 minus 10 is 4 to the power of 2 is 16, and then here we have 2 times 8 minus 10 is minus 2 to the power of 2 is 4. So if we add all of this, we get 96. So the standard deviation will be equal to the square root of 96 over 5, which is approximately equal to 4.38 if we round off to 3 significant figures. And so for the Valencia star, we have to do exactly the same. Okay, with the sum of the deviation squared. So the first value is a 9 minus the mean to the power of 2, and then a 12 minus the mean to the power of 2, and then 11 minus the mean. That's gonna becomes 0, but just let's write it down. Then plus the fourth value, which is a 10 minus the mean squared, plus the last value 13 minus the mean squared. So 9 minus 11 is a minus 2 to the power of 2 is 4. 12 minus 11 is 1 to the power of 2 is 1. 11 minus 11 is 0 to the power of 2 is 0. 10 minus 11 is minus 1 to the power of 2 is 1. 30 minus 11 is 2 to the power of 2 is 4. So 4 plus 1 plus 0 plus 1 plus 4 is 10. So the standard deviation for the Valencia star is equal to the square root of 10 over 5, which is the square root of 2, which is 1.41 approximately. So the standard deviation for the sunblast is greater than larger than the standard deviation for the Valencia star, so we can say that they have more variability, in like the sunblast oranges have more variability. So the sunblast oranges have more variability. Because here it's 4.38, here it's 1.41.